Okay, so this is going to be another air puzzle review. I'm going to be working from the end of packet 2B on creating, graphing equations. So they're going to ask us some preliminary questions. They say, what information do you need to graph a linear equation in slope-intercept form? So let's try not to overthink this question. It says in slope-intercept form. So perhaps these are the two pieces that we need. So first we need our slope. And why do we need that? Because it tells us how fast and in what direction we're moving. And we also need our y-intercept, because that's going to just give us like a starting point. So it asks us, how can we tell if a coordinate point is a solution to the equation? So if it's not on our line, it's not a solution. Because our graph is going to tell us all the x and y points that make the equation true. So if it's not on our, I'm going to say green line, like you guys can see the lines I just had. But if it's not on our line, then it's not going to be a solution. So let's take a look at the first example. It says y equals x plus 1. So let's go ahead and refresh our memories for what slope-intercept form even looks like. It looks like y equals mx plus b. And here I know m is going to be the slope. And note that m is just the coefficient in front of x. And b is going to be our y-intercept. And that's just going to be the constant. And when we write that out, we're going to write it in terms of 0, b. And make sure we include the sign. And there's going to be, regardless if we're dealing with the slope or if we're dealing with the y-intercept, the sign is important. So I'm going to copy that up there, y'all. I hope y'all remember sign. If you guys don't remember anything else, please include your sign. So let's go ahead and identify what the slope and the y-intercept is going to be for this equation. So I know that my slope is just going to be the coefficient in front of x. Since I don't actually see a number in front of x, I know there's an understood 1 there. So my slope is going to be 1. And when I have a whole number like that, I can just write it over 1, because I know a number divided by 1 is just itself. Because this is going to help me see the rise over run, because that's going to help me that's what's going to help me graph. Because I'm going to go up 1 unit and to the right 1 unit. And my y-intercept is just going to be the constant. So in this case, the constant is going to be a positive 1. So I'm going to plug that in. So my y-intercept is going to be 0, positive 1. So now we're ready to start plugging. So I'm going to go to 0, positive 1, which is going to be right here. And then I'm going to go up 1, over 1, up 1, over 1. And I'm going to keep doing that. Ooh. That one really wasn't on the line. So these green dots represent my line. Oh my Jesus. So the question asked us, how do we know if a coordinate point is a solution to the equation? If it's on our line, it is a solution. If it's not on our line, it's not a solution. I'm gonna write that in green. On line equals . So for example, if we take a look at 2, negative 2, that's not on our green line. So that is not a solution. But for example, negative 4, negative 3, that is on our line, so that is a solution. So we could check it that way. So we have 2 more examples. Let's take a look. Y equals negative 3x minus 3. I'm going to go ahead and just write out the form again so we can identify the two different parts that we need. Y is equal, that's not what I meant to write. I meant to write mx plus b. So let's identify the slope. That's just going to be the coefficient in front of x. So that's going to be a -3 because we have to include the sign. Remember, we include the sign. And for the constant, it's just, I'm going to write y-intercept. We need to look at our constant. And that's going to be a -3 because I do see that there is a negative sign in front of both 3's. So I need to include those in my answer. So I know when I write my y-intercept, I'm just going to be writing 0, b. And I said b is -3. So I'm just going to write 0, -3. So I have enough information now to be able to graph this because I do have the y-intercept and I also have the slope. And that's the two parts that I need. So I'm going to start at 0, -3. That's going to be down here. And I know it's going to be down because the 3 is negative. So anytime the 3 is negative, I know I'm going to be over here. Or anytime I have a negative number, I know I'm going to be on that side or that side. So then I see my slope is -3. And I'm going to just write -3 over 1 just so I could get that in the format of rise over run. And again, I'm able to write it over 1 because that doesn't change the value. So from 0, -3, I'm going to go down 3 units and over to the right 1 unit. So let's talk about that. So since my 3 was negative in the numerator, oh, I thought that was the highlighter. This prompts me to go down. However, the 1 is still positive, so I know I need to go to the right. However, I can no longer go down on this side. There's no way I can extend the graph, so I'm going to have to go in this direction now. So I'm going to do the reverse of what I just did to get these answers. So I went down 3 into the right 1, so now I'm going to go up 3 and to the left 1, and that's going to give me the next one. I'm going to go up 3 again to the left 1. So I'm just doing the opposite because I'm going in the opposite direction, and I want to be able to extend my graph so you guys can get a full visual of what it looks like. So this is going to be what y equals -3x minus 3 looks like. And again, we knew it was going to be a negative slope or a negative graph because we saw that the coefficient in front of x was negative. So we have one more example. Y equals 4 over 3x minus 4. Let's go ahead and identify what the slope and y-intercept is. I know m is just going to be the coefficient in front of x, and in this case, that's going to be 4 over 3. That's the number that's directly in front of x. This tells me my rise over run. So according to my slope here, should my graph be increasing over time or decreasing over time? How do I know? I'm going to add that question here so you guys can think about that. And I need to also identify my y-intercept. So that's going to be the b. I'm going to see b is equal to -4 because the constant here is a -4. And when I write that into y-intercept form, I know I need to write 0, b. So I'm just going to substitute that, and it's going to be 0, -4 is my y-intercept. So let's go down to 0, -4 on our graph. I went down to 0, 0, went down 4 units. That's how I found 0, -4. And now I need to do the rise over run method. So I'm going to go up 4 units to the right 4 units. And I know I'm going up and right because both numbers are positive. So I'm going to go up 4 over 3. And I'm going to do it again. Up 4 over 3. So these actually form parts of the system. So how they asked us, how do we know if an equation is a solution? I mean, a point is a solution. I'm going to ask our different points solutions to this system, And you should be able to tell me if they are by seeing if they are on our green line. If they are on our green line, then they are solutions to the system. If they are not on our green line, they are not solutions to the system. Because this is telling us, again, all the different X, Y pair values that'll work. So those are all the actual questions for the Edpuzzle review, but I do want to just include a little table down here. But I am making it as I'm thinking about it, so give me 2 seconds. Just so you guys can have a reference to figure out what direction to move for your slope. And this may be further up. Okay. In this case, numerator NUM is going to be denoted to represent numerator. So I know I have numerator over denominator. The same way I have like rise over run. So that's what I mean. I'm saying the numerator is going to be positive. So that would be the top number. And then that should have been denominator actually. So if we have a positive numerator and a positive denominator, we know I have something like A over B. So I'm gonna go up A units and I'm gonna go right B units. But what if I have a positive numerator and a negative denominator? So I have something that looks like A over negative B. Then I'm gonna still go up A units because the A is still positive, but to the left B units because the B is now negative. So when we discussed in number 1 up in this box, what information do we need to graph a linear equation? We really do need that slope because it's literally going to tell us how fast and what direction. So there's 2 more different possibilities. What if we have a negative numerator and a positive denominator? That's going to be A over B. That's going to tell us to go down A units and to the right B units. And if we have a negative numerator and a negative denominator, that's going to be a negative A over a negative B. That's going to tell us to go down A units. And I'm going to let you tell me what that's going to mean for the negative B. So I do recommend that you guys make this table in your notes somewhere so you can reference it during the quiz, so you can make sure that you're going in the right direction for your slopes. But this is all the content that I have for today. For this Edpuzzle. So thank you guys. Take care and be safe.